These are really, really good friends for you. Really good friends. Yes, they're on the formula sheet. Okay? So I don't ask you to memorize these things, but the more you use them, the easier it'll get to recognize right away. Like there's only one thing to replace sine 2u or sine 2x with. It's called a double angle formula because, look, it's twice the angle. Now that's not the same thing as sine squared u. Squaring something and doubling the angle are not the same thing, okay? So don't get those confused. Some of you, when you wrote sine squared u on your last test, made it look exactly like this. Now, I knew that we hadn't talked about double angles, so I knew that was not the notation you were trying to indicate, so I let it slide. Not a problem, right? I understood you were trying to say sine squared. But it's not the same, and you better make sure that you're writing it correctly so that it's easy to tell the difference between sine squared and sine 2 times the angle. Obviously, there's only one thing to substitute for that one. Okay? And we're going to show how you get those. Okay? Cosine 2u has 3 different choices, so sometimes it gets interesting when you're substituting for cosine 2u because you have some choices. But remember, when we're dealing with these proofs, we know what the end answer is supposed to be, so we get clues about what our substitution is going to be from the answer. Some of you still need to focus on the answer to get your clues on what kind of substitution you need to do. And then lastly is your tangent of a double angle. Now, all of those come from what we did in section 5.3. Now how in the world could we write 2u if we're going to use addition? U plus u. That's how you get 2u. Or 2x, or whatever you want to, whichever variable you feel like using that day. So when we start doing these proofs, I need you to think in your mind, oh, 2 times u can be split up into this. And then we're going back to what we did in the section before it. So just keep that in mind when we start doing some proofs. So let's do it. Let's prove this one. So we've got sine u plus u. You guys just pretty much wrote that down. By the way, I think I forgot to replace on your test the equal sign with an arrow, which I should have, because some of you still thought you could cross multiply things, and that is completely wrong. You have to be able to go from the left side to the right side. Okay, go back in your notes from section 5.3. Figure out what sine u plus u is. Start writing it out. Go back to that formula of that definition. Show me what it is. Yes, nicely done. Think about, does it keep the same sign? Does it go to the opposite sign? Show me what you get. Yes. Is that an equal sign? It should be plus, right? Because it's the same sign. Yes. Open up your 5.3 notes if you can't remember. Go back to your 5.3 notes and think, yes, good job. Now, I'm seeing the multiplied terms. So now you have 2. This is a very quick proof, but you've got to go back to your 5.3 notes. Go back to that 5.3 notes and find that formula for the sum of a sine function. You have your 5.3 notes with you? Okay, well, you need to go back, otherwise you're not going to. Yeah, nice. Nope, I'm going to go back to that. It's not the formula. Go back to your 5.3 notes. You got to get those out. You got to look. If you don't have that one memorized, I understand. I'm not expecting you to memorize it, but You should definitely think. So we got u. Where's our u plus? Where's our have our 5 3's. Just open up those 5 3 notes and you'll see the formula that you need.
Disadvantages.
Sine u, cosine v. Now, why did I say v? Because it's the second one, right? We usually call the first one u and the second one v. Doesn't really matter because they're both the same in this case. What do you think about the sign? Should it be a plus or a minus? Plus, because sine keeps the same sign. And then cosine of the first, sine of the second. Now, what do you notice about those two things? They are like terms. And so, if you have like terms and you add them together, how many of them do you get? You get 2 of them. Isn't that the end of the proof? Sure is. So that was a very simple proof. Anybody need that one any longer? Okay, just like the movie credits. There's more. Are you kidding me? Yeah, there's more. This formula sheet's just going to be loaded. These are called power reducing formulas because you're going from a squared to a linear. But that linear happens to be a double angle. Each one of these is going to a cosine 2u. Now, that does require eventually that we'll substitute something in there. But it's called power reducing because it gets rid of the squared term. Okay. We're going from the left side to the right side. What do you see right there that's so nice?
Something that we might have done back in Algebra 2. They have the same exponents, that's true. Are they perfect squares? They are. Yeah. Is this a difference of perfect squares? Yes, it is. We know how to factor a difference of perfect squares, don't we?
Not anymore.
Not anymore. Are you kidding me? If I said x squared minus 9, what would you break that out into?
Okay.
If I said x squared minus 9 and I said factor it.
X plus 3, x minus 3.
X plus 3x minus 3, right? Do it. Take the square root of each one of those. One's a plus, one's a minus. Go. You can handle this.
Same thing you've done for a long time. All right, so what do you think it should be? Any ideas? Cosine squared theta? Yeah, we could break that cosine to the fourth up into cosine squared theta, cosine squared theta. And then what did you say again? Ooh, you got a plus sine squared theta? Sure. And a minus sine squared theta. Hey, look at that. We took the square root of each. One's a plus, one's a minus. No different than what you just told me seconds ago with the whole x squared minus 9 thing. where we did x plus 3x minus 3. Okay, we're just applying that same knowledge. We're just doing it with something bigger and trigonometrically. Not even a word, I know. If it is, I just misused it. Okay. Can we do any substitutions? Remember, we want something that involves cosine 2 thetas. Hey, we could do all kinds of substitutions, couldn't we? Well, we got let's see, cosine squared. We got a 1 plus cosine 2u, or 2 theta, all over 2, plus 1 minus cosine 2 theta, all over 2, times 1 plus cosine 2 theta over 2 minus 1 minus cosine, running out of room. All I'm doing is substituting with the things that I see up here.
Do the things in parentheses have common denominators?
Yes.
Well, that's pretty cool, because I can make one fraction in each parenthesis. Go. Some things will start happening for us. Make one fraction in each parenthesis. Got to show the steps in between. If you're taking good notes, make sure you're showing exactly the same steps I am. Good observation. We'll go back to that. That's something we'll ask. I like that.
So when you put it into one fraction in each parenthesis, what did you notice in the first one? Yes? It's just 2 over 2, isn't it? Which is just 1. Now, what did you see back here in that black circled area? That's equal to 1. So we could have just said that was 1 from the beginning? Doggone it. I wasted my time. We knew that that was equal to 1 right there. Yeah, that's true. I thought it was, kind of fun to do it anyway. I know you didn't think it was all that fun, but I did. Okay. Okay, how about in the next green parenthesis? What's going on over there? Anything canceling out? 1 minus 1. Now, how come this was a plus? Why is that a plus? Because you had to distribute the negative 1, and some of you might have forgotten that. So how many of those cosine 2 thetas do we have? We got 2 of them, and we're dividing by 2. Anything cancel out? When you say the 2's, okay, you know my greatest fear? That right there would crush my spirit. Okay? We can cancel out coefficients but not the double angle there. That's a killer to my soul. Right? That would work. That is true. Now, the answer up here kind of helps give it away. Which is why I'm saying pay attention to your answer so that you know where you're going. Example 3, reduce a power of 4. Rewrite cosine fourth x in terms of trigonometric functions with no power greater than 1. Okay. Now, what I'm about to write down will get you no credit. No credit. Okay, so you can watch this next part, but if you write down what I'm going to put on the other side of this equal sign, you'll get nothing. Okay? Okay.
It's technically right.
It's technically right now. Okay. Don't do that to me. All right. What I want to see is cosine squared times cosine squared. And what will you be substituting in for each of these? Oh, well, I better go back up here and look, because I ain't going to remember that stuff. 1 plus cosine 2u all over 2. 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 All right. Keep going. What do you think? See if you can multiply those two together. See what happens. Foil might be a good option. By the way, I probably wouldn't put this question on a test. It's good algebra, but it's a little bit ugly. I don't know why I changed those to U's. Why did I change those to U's? What's wrong with me? These don't even look like sheep. U. E-W-E. Oh, yeah. Sorry.
Probably not right. Everything's right.
Hey, got a question for you. Doesn't that look like all the exponents are 1?
Yeah.
Kind of feels like I could stop right there, doesn't it?
Yeah. Like this guy.
Yeah, I some of you were going to ask me this question at different times in this chapter. When can I stop? Doesn't it feel like I could just keep substituting and substituting and substituting? When do I know I could stop? I mean, I understand we need to be extremely specific on our requirements for your answer. Otherwise, I mean, this looks like it's a good place to stop. In the book, they show you that if you do FOIL the top, you would end up with 1 plus 2 cosine 2x plus cosine. Now, what do you get when you take cosine 2x times cosine 2x? Cosine squared, right? This is where it starts getting really ugly. Okay? Because
Because now you got cosine squared, and it's all over 4, right? In the book, they show us, and this is why I don't quite like all of the algebra that they're doing here. They're pulling out a common factor. Oh, I do not. They're asking you to think about this, and how would that look back here? How would it look in here if I did cosine squared 2x? So you would replace every one of these u's with a 2x. So can you tell me what is 2 times 2x? Yeah, and that's what they show in the book. This is why this particular problem, in my opinion, wouldn't be a good one. Because they're doing this. They're saying, oh, is that kid going to realize that this is 1 plus cosine 4x all over 2. I mean, folks, this is ugly. Look at this. It's all over 4. I'm not going to have a question like this for you guys to worry about because these particular reducing ones sometimes can get extremely ugly. And if you look at their answer, look at what they did. What did they pull out of, or what? It's like they pulled out a 1/4 there. It's extremely ugly. In fact, the final answer that they list has a 1/8 out in front. So they went through and they pulled out a 1/8. I promise you 0 of my students would see that. Okay? So this particular example, as I said before, right in here is a good place because you don't have any more exponents higher than 1. Yeah, I'm not a fan of that particular question because it gets too ugly. Okay, before we'll do half angles tomorrow. Let's jump down to homework. Start doing some questions together. Definitely odd ones. I just want to be consistent, so it's not like, some of the odd ones I don't like. She asked about an odd one the other day, which I took off the list because of that whole cotangent pi over 2 issue. So I get selective with some of the ones that I want toward the end, but a lot of the ones in the beginning, I just want to be consistent, unless I see some real serious ugliness. Question 1. So what are we going to do with the 2u there? We're doing odds. I would have, I know it goes past 1, but I'm going to have to check on my calendar. So what would I substitute? I'll go check the numbers here, but what would I substitute for 2u? U plus u. It's a whole flock of u's. Did you get that with the whole flock? Okay. Sorry, shepherd jokes. Too early for those. Use the formula. Go back to 5-3. Use your formula. Substitute in. Come on, use the formula. I always want to say use the formula. You're the only kid I can see that. Oh. Princess Leia quote right there. Help me, 21. You're my only hope. 21. I'm on a roll here, man. On a roll.
I just want the Chewbacca shirt.
Yeah, somebody suggested I go with chewing gum. That would have been a little bit more school friendly. I might have to redo that one.
So then you could actually wear your merch.
Oh yeah, I will. I ordered like 7 of them last night, so I will start wearing my merch. Some are serious, some of them are funny.
So now in all your recordings, you kind of like your merch shop.
At the bottom, I'm gonna go
Yeah.
back to YouTube now.
Put a link in the
In the bio.
You need to make a shirt with your song lyrics.
That's an idea right there.
Song lyrics.
It's an idea sheet.
I know, so little time.
I don't have enough money.
You have all the time.
Well, I don't expect you guys. I'm
I'm
looking for the other people. No, don't do that. Don't do this.
Ooh, I like it. So remember how there were 3 versions of this, of substitutions for this, instead of just one? Found one of them. Nicely done. Alright, so we gotta go to the cosine formula. Where'd you go from there? Oh yeah, so there's the one. So it's plus u, right? So we gotta do this, and it switches signs, so it'll be minus 6. Yep. And the u and the v are both u's. Yes. Very well done. Yes, very well done. Oh, I'm sorry. So what they're going to do is the other side. Substitute this with the Pythagorean in. Hold on to that. Yeah. So you're going to do the same thing you started with here. So you're going to get to this point, and we got to go one step further. Okay. Several of you got number 1, so let me catch up to you so we can do number 3 together. Okay, so 2 would be a good one too. All right, so hopefully you, whoops. Oh yeah, I want to draw a tool. You said cosine of the first, cosine of the second. What'd you do in between? Subtracted. Sine of the first, sine of the second. And then you said, oh, well, that's the same thing. So that's cosine squared minus sine squared. Okay? Now, you found the insert that we wanted for question 1. Since question 3 is very similar, okay, we're going to go right to question 3, and we're going to act like this is a continuation. Instead of me recopying all that crap, we're going to make like it's a continuation, all right? Because the truth of the matter is you would be doing the same thing. But notice that they want my answer to only have sine squareds in it. So what are you going to replace this with? Don't go back to the power reducing formula. Let's make it all sine squareds. So let's think easier than that. Go back to your Pythagorean identity. Remember that cosine squared plus sine squared equals 1? So we're going to replace this with, if that's that, cosine squared u plus sine squared u equals 1. What would we replace cosine squared with? 1 minus sine squared. And then, of course, this is right here, minus sine squared. So what do we get? 1 minus 2 sine squared. Hey, we're done with question 3. Question 2 is extremely similar, right? I know that's not in your list. But can you tell me what to do? What would you have done to this right here, the cosine squared minus sine squared?
What would you have done to that to get the answer for question 2? You would have changed sine squared, right? It would have had cosine squared u minus 1 minus cosine squared u. And then, of course, what would you do? Oops, sorry. What would you do with this negative 1 that's out in front? Distribute it, right? And when you distribute it, you would get exactly what they have in question 2. Yep.
So I'm just how you got 1 minus sine 2 squared u.
Okay, how you're wondering how I substituted right here?
Yeah.
Okay. If you go back to the basic Pythagorean identity that we did way back in section 1, and you solve that equation for cosine squared u, all you would be doing is you'd be moving that sine squared to the other side. That's 1 minus sine squared u. So all I'm doing is algebraically subtracting that term to the other side and then substituting there. And then I had 2 like terms that could be added together to give me the minus 2 sine squared. Okay, takes care of that. Let's go down here and see if we can find all the solutions to this equation in the interval from 0 to 2 pi. Is there anything that you would substitute for sine 2x? Anything that we could substitute for sine 2x? Look back. What? Isn't there only one choice? 2 sine x cosine x. That's what that was in the blue box. This is an equation. We're trying to find angle measurements between 0 and 2 pi that make this thing true. What should we do next? Subtract. That's a great idea. Push all the terms to the same side. Yeah, this is different than a proof. What do you think we should do next? Pull out the GCF. What's the GCF? 2 sine x. Great idea. Pull it out. In other words, you are factoring it. Solve for the angles. There will be 3 answers to this question. Find them. Factored out the 2 sine x. Set your factors equal to 0, just like you did in Algebra 2, and solve them. Yes, so that gave me, now this should only spit out 1 answer, and neither one of those is correct.
What do you do with
Set this factor equal to 0, set this factor equal to 0, solve them. Set each one of your factors equal to 0, solve them. So we pull the 2 sine x out in front. Well, if I pull the 2 sine x out, what am I left with in the first term? So I have my 2 sine x parenthesis. What's left here? Cosine x minus 1. Right? In parentheses. Set each one of your factors equal to 0 and solve them. Get something like that?
Yeah.
Set your factors equal to 0 and started solving, so sine x could be 0 or cosine x could be 1. Then you said, okay, let's go to my unit circle and figure this out. Sine, is that an x value, a y value, or a slope? It's a y value, right? So where do we have y values that are 0? Where do we have y values equal to 0? Well, one of them would be 0, right? And the other one would be pi. Ooh, I was wrong. There's only 2 answers. Why was I wrong when I said there would be a third answer? What's the cosine is an x value, right? Where on the circle do we have a cosine of 1? Yeah, it's over here at 0, but we already wrote that answer down. So copying it down again, well, there's no real point to that. Got that one? I need to get to 7. For shizzle. Question 7. We need to substitute something for cosine 2x. Now, you know from what we looked at earlier, there were 3 choices. We even saw that up in questions 1, 2, and 3. What should I choose? You're right. Whoever said that? Who said it? Who said the 1 minus 2 sine squared x? How do you know that? The right side gave me a big old clue. You need something that only involves sine. So choosing cosine squared minus sine squared, not a good option. Choosing cosine squared, not a good option. We want the 1 minus 2 sine squared. That would be a good option. Yeah, I got it right over here. Okay, what do you think we should do? We could, but I really like dealing with positive squared terms. So I'm going to push everything over to that side. So 2 sine squared x plus 1 sine x and a minus 1. Now what? I got a squared term, a linear term, and a constant. What did we do back in Algebra 2? We factored it, yes. Any GCFs to pull out? No GCFs. So straight to the binomials. 2 sine x and 1 sine x. Now what? It's plus 1 minus 1, but where? You got to be careful. Where does the plus 1 go? Goes on the right, because you got to have the outsides positive and the insides negative so that you end up with a positive sine x. Once again, set your factors equal to 0 and solve. So over here, what's sine x going to equal? 1/2, right? And over here, sine x is going to be -1. There should be 3 answers here. I know. You want to go to lunch. Go. You guys will have to finish that one. now that you're all out of the room, the y value at -1 would only occur at the bottom of the circle down here, and that's why I wrote 3 pi over 2 is that answer. And then the y value being 1/2 would cut through at pi over 6 and 5 pi over 6. So 3 total answers on that question.